Hello and welcome to the IMCSB podcast with me, Anir Pandit. With us today is our new podcast host, Miriam Scarpa.
Hi everyone, I'm very glad to be taking this position. Well, I've just introduced myself. I'm a PhD student, now started my third year in October, and supervised by Sophie Bradley and Andrew Tobin.
Welcome to the podcast, Miriam.
Thank you.
Today our guest is Professor Richard Cogdell.
Yeah, Professor Cogdell has served as Chair of Botany, Director of Glasgow Biomedical Research Center, Director of the Institute of Molecular and Cellular Systems Biology, and Deputy Head of College of Medical and Veterinary and Life Sciences. Wow! He has won multiple awards and is the author of more than 250 publications in various journals.
That is amazing. And I'll tell you what, I actually went to do some research on you, and the first place I found online was that you're in Who's Who. That's amazing.
I think that goes with old age. I don't think there's anything particularly special about that.
But no, that's amazing. And I was like, wow, so many positions and so many. So as you said earlier, you've been here since 1975.
Yeah, I came in November 1975 and never really thought I would survive or stay this long. I turned up with long hair, a necklace, flared trousers and clogs, and somehow they gave me a job and I never managed to escape.
Ooh, a necklace.
A necklace, yes.
Well, okay, if we start with the career path, where did it all start?
Right, so I started as an undergraduate in Bristol.
Right.
And did biochemistry as my first degree. And then stayed on to do a PhD in biochemistry. And then went to do just about 2 years postdoc in the States. Part of the time in Ithaca at Cornell University. Part of the time in Seattle at the University of Washington. And then after that, I was looking for a permanent job. My wife and I wanted to come back to the UK and have children where they would know their grandparents.
Right, okay.
And Glasgow took me on.
Right,
And
okay.
I've been here ever since.
Wow. So you've been to America. Is there any other places where you did work?
Not before I came here, but since then, I've had the possibility of doing several sabbaticals.
Right.
So I've done 3 sabbaticals in Germany, one for a whole year in Berlin, and 2 extended periods, one in Munich and one in Bayreuth. And I've also done 2 or 3 month sabbaticals in the States.
Right, okay.
One in UCLA and one at the University of Illinois in Champaign-Urbana.
How would you say the progress went from your earlier career to now?
I think I've been very fortunate. I mean, when you look back and you think of the big decisions that you made or you didn't make, but just happened to follow various things that you were interested in, I think I was very lucky to be wanting to get into understanding the primary reactions in photosynthesis. And when I was in the States, I was involved in some very early reactions on reaction centers. It was the first time that laser physics had advanced to allow you to have short enough pulses to actually measure these reactions, which are very fast. And I was involved in some of the very early reactions to do that. Long before the crystal structure of the reaction center came out, we had nailed the electron transport pathway in the purple bacterial reaction centers. And then when I came here, I realized that I couldn't continue working on reaction centers because it was far too competitive.
Right.
When I turned up here to an empty lab with a centrifuge. And so you have to think about what you're going to do that gives you enough time to learn to be independent before you get onto things. So I decided I would work on light harvesting complexes rather than the reaction center, at a time when most people in the world didn't even believe that there were light harvesting complexes.
Yes.
But I knew there were from the basic biochemistry. So that gave me enough time to develop that area and not be afraid that a big group somewhere would come along and stamp on me before I'd actually been able to do anything.
Right.
And I think in those days too, there wasn't the pressure to instantly become a world expert and to succeed.
Right.
You were given time to learn how to be independent, to make mistakes and not be pressurized the whole time to be delivering all the time. And I'm very grateful that I was given that time here in Glasgow to actually learn how to run a group, how to be independent, how to do science by myself, how to develop the imagination to do those experiments. And by the time that everybody else realized it was an interesting area, I'd done enough that I was competitive.
No, yes.
And people wanted to work with me rather than to compete with me. And so that worked very well.
Good, amazing. So, I mean, my question again was on the light harvesting complex was a bit of a cheesy one. You are associated with what is considered as a world-changing achievement with the light harvesting complex from photosynthetic bacteria. Could you shed some light on that?
Yes, yeah, it's not a nice cheesy thing. I was spending the extended period in Munich with a friend of mine at the Botanical Institute, and he told me that a young guy in Munich had learned how to crystallize membrane proteins. This was Hartmut Mickel, who went on to win the Nobel Prize for crystallizing the reaction center. And so I made a contact with him and persuaded him to teach me how to crystallize membrane proteins at a time when no membrane protein had its structure determined by X-ray crystallography. And very quickly we got some crystals of the light harvesting complex. And so I was able to come back to Glasgow and start to see if I could get these crystals into good shape that would allow me to determine the structure. And I was very fortunate that the chemistry department took on a really good crystallographer, an Australian guy called Neil Isaacs. And we worked together for 13 years until we actually got these horrible, small, unresolving crystals into large, big ones, and we could solve the structure.
Right.
And when we did that, we found to our delight the structure was a marvellous structure. It really informed how we understood it worked. And it was only the third membrane protein ever to have its crystal structure determined by X-ray crystallography. So we were right at the beginning of that process. And so I think at the beginning, if you'd have asked me, would I have been prepared to spend 13 years doing it, if I knew it was going to take that long, I may not have been brave enough to do it. But once you start, you always think it's going to work. And so you carry on and you carry on. And I was very fortunate. At this time, BBSRC highlighted the structure determination of membrane proteins as one of their key areas to develop. And they invited the few people in the UK who actually could crystallize a membrane protein to join that program. And Neil and I got a long-term grant that actually allowed us to have that time to do it. Because if you've got a 3-year grant and at the end of 3 years you've not
to show something.
done anything,
Yeah.
then it's very difficult to keep it going. So we were very lucky that's why I say, you need luck. It allowed us the time to actually do it. And then once we got the structure, then there was a queue of physical chemists wanting to work with us to really understand how it works. And it just ballooned like that. It was a very interesting process because when we'd actually got the structure, I was very excited. But then I had a period of really deep bereavement, really, because you think, I've struggled to do this for 13 years. Now we've done it. What the hell am I going to do now? And it was quite scary all over again as to what we were going to do. But then, of course, all the functional work came, and that's just gone on to be a lot of fun. I mean, I was trained as a biochemist with a little bit of biophysics. I mean, in the days when I started, you wouldn't believe how much you had to make for yourself. So that when I started my PhD, I had to build a spectrophotometer.
Wow. Okay.
So the first month I was in the workshop making a table, building boxes, doing wiring up of amplifiers and phototubes to actually get a machine that could work, because you couldn't buy it.
Gosh. Okay. And you're trained to do this?
Of course not.
Yeah.
Right.
You had to learn.
There's
And
no
I guess,
internet.
yeah.
There's no YouTube.
There was
that's
no
what I
internet.
Exactly.
There were no computers. Well, there were computers, but you had to, big wads of computer cards before you could do any programming. So, you just had to learn to do it. It was just one of those things that you did. So I was primed to do that sort of stuff. And then once you start interacting with some of these physical chemists, the techniques are really challenging for a biologist. So you have to actually be brave enough to take that leap of faith into the dark, as it were, but it's going to work out. And you realise that you depend on good friends. So people that I got to know at my first meetings actually became my collaborators for life. And I mean, we've become family friends, our children stay in each other's houses and all this in the business. And that's what's really sustained all of this work, is actually having those friendships with people who
good
can do these
relationship,
things.
yeah.
Yeah, very important.
Well, that's just amazing. Now you can just go, as you said, you could go, if you want a certain piece of equipment, you go buy of course you write a grant for it, you get money for it, and you go buy it. But
Sure.
the fact that you had to actually build your own.
Well, I mean, you couldn't even buy a gel apparatus in those days.
Wow.
So if you wanted to run a gel, you had to go downstairs and make it. Okay, you had to make the apparatus for the thing, and you had to actually do, all the work to do that. A friend of mine, at the same time as me, a year above me, was working on restriction enzymes. You couldn't buy them in those days. So before he could do his experiments, he had to spend 2 years, different bacteria, actually making all the restriction enzymes before he could do his science.
Wow.
I mean, it's very hard to think what it was like in those days.
Right.
Yeah.
But then when you are an expert in that, you are really truly an expert because
Yeah.
you have
Yeah.
done
Sure,
everything
sure,
on it. You have
sure.
from the start to the
Yeah.
That's amazing. I mean, I think probably the scientists of today or the scientists of tomorrow rather should also have those skills.
Yeah.
They are problem solving at the end of the day, I guess.
Well, there's a program that brings American students over to the UK
Right.
each year, and every second year when they do their round Britain trip, they come to Glasgow. And
Right.
2 years ago, I spoke to these people talking about these sort of things, and I took in a slide rule, and of course they had no idea what a slide rule was. So I challenged them to do a calculation. They took out their phones, and before they got their phones turned on, I'd done it with a slide rule. So it was a different time, and the things you had to do and what you learned was a different way. It's, you can't go back, and you shouldn't go back because you can do so much more now. But I think you really had to understand the basis of what you were doing in a way which was not the same. With the internet now, I can't remember the last time I went to the library.
Mm-hmm.
Everything's online. When I was a PhD student, you would go down each month and wait for the physical journal to come and then sit there and go through it and try and find whether there's anything you wanted to read.
But also the way of reaching out to people. Like, for example, as you said, there's this German expert on the crystallization of proteins. How did you reach out?
How did I find him?
Yeah.
It was interesting because it turned out we were both invited to a meeting in Bari in southern Italy. And I found myself in the same compartment as him on a slow train from Milan to Bari. Okay? So I realised who he was because I'd seen a
Italian
picture
chief.
of him. So I badgered him all the way down to Bari. Can I come to your lab? Can you teach me? And he'd got hay fever.
Oh, no.
So he was sitting in a corner feeling sorry for himself, streaming, and I eventually wore him down. And he said yes. So that after the conference, then I went back and spent a few days while I was in Munich in his lab learning how to do this. And that was we've been good friends ever since, of course.
Yeah, that's funny and then also very cool because I feel maybe now so the way we do things like with emails and or websites or whatever, it just takes out a bit of the personal side of it.
Everything's more immediate now.
It's more,
I
yeah.
was going to
We
say,
had more time.
Yeah, I was just going to say that there's not time.
There's not
no
less time
in it.
now.
Nobody has time anymore. Yes.
That is true.
I can't waste my time on you. No, I have my own stuff to do. But yeah, but collaboration.
Actually, you must make time because time is very important. If you think there's no time, you put immense pressure on yourselves, and that's not good. It's not good for the way you develop as a scientist. It's not good for the way you develop interactions and friendships. It's all about making time. And actually, although it looks like you've got no time, you do have that time. You actually have to be brave enough to stand back and say, I'm going to take the time. It's very important.
What's your view about, well, for example, time or career progress now compared to then?
Yeah, I've always believed if you do good science, you'll make it. And I think it's always been hard, but if you allow yourself to be spooked out, that there's always going to be someone who's better than you and you're never going to make it, you're never going to do enough to do it. You spend all your time worrying and not enough time doing the science. I think if you really want to do it, you've got to make the time and be brave enough to do really good science. If you aim high and just miss, you'll do great. If you aim low and are safe and do well, no one cares. So you've got to actually be brave enough to aim high and go for it and really tackle important problems, not just a little bit more than what somebody else has been doing, but really be brave enough to take on something that may take you some time. You may not know how you're going to solve the problem, but it's important to be brave enough to try that. And I think it's also important where you can to train with different people. So you get different ideas, different ways of thinking about things. And I was lucky because I had a very good PhD supervisor and the people I did my postdocs with were still working in the lab. So I was able to work beside them and with them, and that I found that was very important. I wouldn't have wanted to go to a large group where the boss sat in his office and didn't do anything, barely knew you and what you were doing. One of my friends in the States went to a large group, and he was giving a poster at a meeting, and his boss came up and looked at the poster and said, wow, that's really great. How long have you been doing this? And my friend said, I've been in your lab 2 years and we've been doing this together. And the guy hadn't realised. And I think that's what I would never want for anyone. So when you go on, when you finish your PhD, when you're being a postdoc or whatever, before you, hopefully, if you want to, develop your own groups, then it's much better to choose someone who's really into the experimental stuff and in the lab with a smaller group, rather than to go to a huge group where you're just cannon fodder for one person.
Sounds good.
That's a great piece of advice for all our fellow PhD
I guess so,
students
yeah.
and
I mean,
early career researchers.
some of this advice I don't think PhD students actually get, so that's very nice.
Well, let's go back to the science. Could you explain in a layman's terms what your group is working on now and what types of techniques?
We have to change the question a little bit,
Yes.
because I no longer have a group,
Yeah.
because I'm only 2 days a week now on the way to retiring.
Fair enough.
I'm 70, and so it's towards the end of things. But
Can I just stop you there? When you said, I was calculating, I saw your birth year was 1949.
yes,
And this morning I was thinking, gosh, that's 2019, so that's 70. I never thought you would be that age at all. I mean, I think I first saw you 5 years ago when I started whistling down the corridors of the Davidson. I never thought you would be 70, so that's amazing. Sorry for that tangent, but
that's very kind of you to say that. No, I'm lucky to be healthy. So I'm drawing to the end of finishing off the stuff on light harvesting that I've been doing. But what I'm doing quite a lot of at the moment is things related to climate change. So I've been giving quite a few lectures, both in this country and around the world. I was giving a public lecture in Japan just 10 days ago, trying to show people how important photosynthesis is in terms of cleaning the air of excess CO2. And showing how important it would be to develop systems for artificial photosynthesis. Because if we could use solar energy in the way that plants do, but more efficiently, to pull CO2 out of the atmosphere and to make a fuel, then we'd be able to bring the atmosphere back into balance. We'd be able to even reduce the amount of CO2 because the excess stuff you could stick back in the ground. And oil and coal is stable for millions of years. And so we can produce electricity renewably very easy, with solar panels or windmills or whatever, but we can't store it. And we haven't got a smart grid, so the intermittency causes a problem. So if you look at the primary action in photosynthesis, in the reaction center, light energy separates charge across the membrane. It's rather like charging up a battery.
yes.
Okay? So if you could use that separated charge to do the chemistry, then you solve the problem. Now, unfortunately, so far, all the catalysts that chemists produce that activate CO2 really are not very effective. They only work at high temperature and atmospheres of CO2, which is almost 100%. Rubisco, although it's a flawed enzyme, is able to work at 0.04% CO2. So what we've got to try to do is to learn how to replicate what photosynthesis does, but in a way which is efficient. The natural process wasn't designed to make energy for us. And so if you go out to a field in Scotland, the efficiency of converting solar energy into the plant is a fraction of 1%. And so you've got to get that up, because there's a lot of solar energy, it's the surface of the Earth, enough each hour to provide for what we need every year. But there's not much per square metre. So if it's inefficient, you need a large land area to harvest the light energy over. So you've got to be thinking in terms of hopefully being about 20% efficient, so that the land usage requirements are not too high. I have a friend in Holland who calculated if Holland wanted to produce all of its energy at the efficiency that photosynthesis does, so use biomass or whatever, you'd need the whole area of Holland, the whole area of Belgium, the whole area of Denmark and part of Germany, and there wouldn't be any space for you to live or grow your food.
Okay.
So doing it with biofuels or whatever is just horribly unsustainable. So we've got to learn the chemistry that's done in biology and allow the chemists to develop efficient catalysts to drive that reaction from electricity to actually allow us to fix CO2 and to solve this problem. So we need to do two things. And what I'm trying to do is to persuade people of this argument, trying to inspire young people, chemists, physicists, biologists, engineers, to actually dedicate to solve this problem. But also persuade people that they've got to do their withal to change the way they live and use energy, to save energy, to save fossil fuels, to give us the time to do the basic science to solve the problem. And this is what disappoints me when I hear the politicians talking about climate change with no plan, just setting targets. They've got to be much more clear thinking in terms of we need to make the time and then we need to put the resources to solve it. And these are not going to be small grants. This is going to be billions over 10, 20, 30, 40 years. And until we make that commitment, we're just doing lip service or something. And this horrible environmental steamroller is coming up behind us and it's going to squash us. I mean, I've been very lucky in my life and I've had a planet that's been marvellous to live in. I want my children and my grandchildren and their children to have the same place to live. This is important. So you asked me what I'm doing. That's what I'm spending most of my time doing now.
That's amazing. So is your work part of any bigger organization as a consultant to someone? Or?
No, I belong to various conferences on this sort of thing that happen every now and again. So we all try to contribute to do this, but there's no real organisation as such.
I was just wondering, I mean, with these ideas, I'm guessing there are many bodies, I'm guessing, thinking about various ways of doing it.
Certainly.
And what can be done towards encouraging...
I think one of the most important things to realise is that this requires political will.
Yes.
And it requires a long-term attitude to the problem. And as long as you've got politicians who are only concerned with getting re-elected in 5 years' time, they will never do what they should be doing in this regard unless the general public say we aren't going to vote for you until you do it. And so there's a great deal of work to be done with the general public, making them bring this to the top of the pile and really make it so that the politicians have to do something about it or they won't get re-elected. A good example of what I'm talking about is if politicians said they were no longer going to fund cancer-based research, there'd be outcry. They would never get elected. That's almost out with politics now because it's so important. The climate change agenda has to be the same. It has to be as important or more important than that. And if young scientists like yourself want to do this, you have to know that for your career, this long-term funding is going to be there in the same way it would be if you want to tackle cancer research.
Yes.
If you're good at cancer research, you know there's always going to be money. That's got to be the situation in this area as well.
Are you optimistic about
I am
this?
optimistic, otherwise you'd get too depressed.
No, of course, yeah.
So I am optimistic, but you know the state of the politics in this country and in America now is so bloody awful that you could easily be unoptimistic. But the young people give me the optimism because they're now taking up that banner. They're committed, and the old guys like me have got to try to create the situation where they can carry on with this in a way which is constructive and really solve it. It's not going to be me that solves the problem. It'll be bright young people with new ideas.
That is very strong. Yeah, okay. Don't want to move on, but because this is a very interesting subject itself.
Do move on. It's fine.
But yeah, no, we possibly won't have much more time because we want to get a couple of more personal questions as well. But one of the questions that came up from, we gave an audience questions. And one of the questions which did come up was, in your long and illustrious research career, what is the biggest change you have seen in academia?
Oh, goodness me. I think the biggest change is the way in which publications are judged and then the behaviour that's instilled in reviewing. When I first started to write papers, if I made a mistake, the reviewers usually were supportive and would suggest ways not to kill the paper, but for you to put right any mistakes. Nowadays, I have the feeling that a lot of the reviewing is trying to say no to papers rather than to improve and to get them published. And there's a completely outrageous reliance on impact factors. I mean, there are some horrible papers published in Nature.
Oh, yeah.
Horrible, barely scientific. And yet no one is prepared to do the work to read the papers properly, irrespective of where they've come from, to evaluate the science properly. So it's too lazy to judge someone only if they've got Nature papers as being good. And if they don't, they're no good. Sometimes papers require the space to explain the methods properly and to really go through the results in the paper, not in screeds of supplementary material afterwards. And I think when I was growing up scientifically, all of the best work in photosynthesis was in a journal called BBA. Nobel Prizes were won on papers published in BBA. If you only publish in BBA now, you barely get a job. And I think that's been the biggest change that I've experienced in terms of that. And I think we've allowed things to get out of balance in that way, which is not good. It's hard to reverse it, but I think it's something I regret.
Is it because of maybe commercialization of the journals?
It certainly is because of commercialization of the journals, but it's also a lazy way to allow people to make judgments about other people without really looking at their science.
On the ability to publish in a high impact journal.
Yeah.
That's interesting. Okay.
Yeah. I had one question /2. So you won multiple awards.
Yeah.
Which one is the one that you're most proud of?
I think the one that gave me the greatest pleasure was to win the Humboldt Research Prize, because that allowed me to go to Berlin and live in Germany for a year, completely paid for by this. And it was a marvellous experience because they look after you very, very nicely as well. So it's not just that I could go there and work in Berlin for the year, but there were all sorts of other things that the Humboldt Stiftung did for you. For example, they invited my wife and I to a long weekend in Bordeaux.
Oh, wow.
Where we had scientific discussions, but also did a little wine tasting.
Yes.
That's lovely.
Which was just spectacular. So it opened all sorts of other things as a result of that. And that was a marvellous experience.
And counter question, which one is the ones you regret not getting?
Oh, goodness me. I mean, I think if you allow yourself to worry about getting prizes, you can become very bitter and twisted if you don't get them. I think if they happen, it's very nice, but you shouldn't allow that to be something that gives a judgment on your whole career. I think the most important thing for me is how I and my science is viewed by other people in my field who I respect. And as long as you get good feedback there, I'm happy. If you get prizes, it's nice, but it's not really the be-all and end-all. There's lots of things go into getting prizes or not getting prizes that have nothing to do with your science. So I think it's much better to have your feet on the ground and not worry about that. If they happen, they happen. If they don't, well, don't worry.
I like this approach.
As part of our podcast, we ask our guests a quick fire round to get to know them better. And from feedback that I've gotten, some people really, really like to learn more about people.
Okay, fine, yeah, sure.
So if you're okay,
yeah, of course.
We can ask one each.
Yeah, I can
I'll
start.
see where it goes with this, of course.
Okay, so favorite food?
Favorite food? I mean,
That's a hard one.
that's very hard. I'm extremely greedy and I like food, okay?
Tell me about
I
it.
have a very sweet tooth, so I like puddings very much. But I also like fish very much. Really good, well-cooked, fresh fish, even raw fish. I go to Japan a lot, and sashimi from really fresh stuff is just magnificent and completely different than eating cooked fish, which I also enjoy. But I think fish.
Excellent.
Nice.
So did you fish yourself?
I tried once or twice, but I never had the patience for it.
Just eat it.
I'm sure that because there are quite a few ponds around
Yeah.
Glasgow,
Sure.
where you can go and catch your own.
Absolutely,
as they
yeah.
say that. But it's
Well, Craig Carr, the technician in the building, is a great
Yeah.
fisherman.
always you.
So sometimes when he has too many trout, he'll give me one.
Yeah.
So that's very nice.
Nice of him. Excellent. So you've been in Glasgow since 1975, but what your favourite city is?
Let me make a comment about Glasgow first, and then
Okay.
I'll tell you my favourite city outside of Glasgow. When I first came to Glasgow, the buildings were black, and the people were almost reluctant to say they came from Glasgow.
Right. Okay.
The biggest thing that's happened since then is it started off with one of the Lord Provosts, Michael Kelly, getting EU money under a slogan, Glasgow's Miles Better, and using it to clean the building. And all of a sudden, this gorgeous late Victorian Georgian sandstone city appeared
Yes.
out of the grime. And that had the benefit of making people to be proud to say they come from Glasgow again. And that's been the biggest change in Glasgow, and something that's been wonderful
Right.
to see. My favourite city. I mean, I think the one that I enjoy most now, but it's because I know it best, is Berlin.
Right, okay.
I spent a year in Berlin. I'm comfortable there. I know my way around it. I like the style of life there. My son lives there
Right,
with
okay.
his family. So I mean, I think it's a wonderful place.
Fantastic. I mean, yeah, I had an opportunity to go to Berlin. Funnily enough, my daughter competes in karate competitions here and there, so because of her, we get to go and see these cities. And I went to Berlin not really expecting much, but it's beautiful.
Yeah.
It's humongous, but it's easy to get around as well.
It's a very nice city. It's a very green city. It had lots of parks. The people are very relaxed in Berlin
Right.
and very tolerant, and I like it very much.
I would agree with you then.
Next, what's your favorite music? I guess band or
Oh yeah,
musician.
When we were strangely enough, when we were in Berlin, because we were there a long time, we were able to, for the first time, to go to opera
Right.
because it was cheap in those days, and you could turn up on the night and you could buy a ticket and get it half price.
Right.
And they were a very nice thing because you buy the cheap seats. When the lights went out, if the expensive seats weren't full, you could migrate down and sit in the expensive seats. So we got to like opera for the first time, which I never had done before. But, I mean, all of my music goes back to the 60s. So, I mean, bands like the Rolling Stones, the Beatles, the Who,
Right.
all of these things. I mean, I saw them live.
Wow.
I mean, I saw the Who in the Union in Bristol in front of 100 people. And, you know, when you've done that, I mean, you're hooked.
Oh yes, I can imagine.
So that, I mean, I like all that music much better. But that's only because I really haven't taken the time with more modern music.
But the classics are the classics, I can imagine.
And
because-
they're still good.
Oh yes,
Yeah.
absolutely, yes. My son is 6 and he still rocks out to Led Zepp. I say still rocks out. He rocks out to Led Zepp
sure.
as well because and Queen, unfortunately. But yeah, he does like them. But yeah, as you said, you came to the Glasgow University with long hair and necklace and flair. So I'm guessing a bit of the 60s
Clearly.
moved with you. That's amazing. And so, did you yourself play any instruments?
No, I never had the chance. I think looking back, I would have liked to have done, but I never did. I spent more time playing sport than that.
Which of course leads us to the next question. I'm guessing from your right up there, your favourite sport is cricket?
Yeah, absolutely. So I was lucky enough to play a lot of cricket at school, and actually Bob Willis, who just died this year, or did this week, was in my class, and we were in the same team, and for the first 5 years at school I was the captain when he was playing with us, and of course we never knew he would go on to be a captain of England and such a great cricketer.
That's amazing. Was he good then?
Yeah, he was very good then, but I wouldn't have said he was the best in the team. But, you know, obviously he had something that was required to go on. You have to have that determination. He was always very talented. Quite scary as an under 14, having someone come charging in who bowls that quick. Yes. He didn't get much quicker. And so that was... and then when I came to Glasgow, I played for the university staff team.
Oh, cool.
For more than 35 years.
Wow. Okay.
And that was really great because it meant I got to know lots of people, and I know people throughout the university in all different departments now from playing cricket, and that's been very, very helpful when I sit on various committees because you know people and instantly that breaks down all the barriers. So that's been something that's been very, very nice.
And you can talk about any particular matches as
Absolutely,
well?
absolutely, yeah,
Great.
sure.
Okay, and what position? Oh,
I was a spin bowler.
oh, wow, okay. Spin bowler, okay. Shane Warne?
No, I've seen Shane Warne play, and he was a brilliant leg spinner. But I think the guy that I idolised when I was small was a West Indian spin bowler called Lance Gibbs,
Yep, okay.
who was just fabulous.
One of the rare spin West Indian bowlers.
Absolutely wonderful.
Cool. And you still play?
No, my eyes have gone. I've got rheumatism in my fingers now. I can't grip a ball anymore, so I've stopped. When you get to a certain age, it's natural to stop, and you don't miss it. You miss the friendship, but you don't miss the playing anymore.
Did you go watch the matches, or did you last year when?
This summer I went to 3 days at the Old Trafford Test match, and I have a cousin who's a bit older than me, and we went and spent 4 days in Guildford to watch Surrey play Somerset. He's from Somerset, and I'm from Surrey, from Guildford.
Right.
So we spent 4 days together watching the whole match together, which is nice. It's nice to have the time to do that.
Oh, absolutely, yes. Oh, that's amazing. Well, I come from India where it's a religion, but funnily enough, I was the wicket keeper. A bit a lanky one though, but I did not have as much fanaticism about it as my friends did, and I found myself I love the game.
Mm-hmm, sure.
I cannot talk so much about the statistics of some bowlers.
Sure.
But that is another thing as well. Okay.
Yeah, what's your favourite movie?
When you gave me the list of questions, I thought about that. I found that very hard. I like the movie Zulu, which is a movie about the fight between the British and the Zulus in South Africa. One of the movies that had most effect on me, because we went to see it and I didn't know anything about it beforehand, was One Flew Over Cuckoo's Nest, which was an amazing movie, and I came out sort of stunned at the end of that.
So the ending was quite
harsh.
Different. Yes.
Yeah.
I'm just trying to remember. Zulu, was it Michael Caine?
That's right.
Right. Yeah.
So I like lots of these sort of movies, but I tend to go and see them, enjoy them, and then not spend too much time analysing them.
Yeah. And so, favourite TV show?
Show on TV? Goodness me. I would have to say Monty Python's Flying Circus.
Right.
Okay. And for two reasons. One, because it was brilliant, and two, because the head boy at the grammar school I went to when I first went there for the first 2 years was Terry Jones.
Okay.
So that always impressed me. And then in years since then, his first wife worked in the same area as me. And when we lived in Berlin, she came to stay and to do some work in the institute I was at. And Terry came and stayed with us in our house as well.
Wow. Okay.
That's
So
cool.
I got to know him again later on. So for those personal reasons as well, Monty Python's Flying Circus.
Yeah, but I mean, it comes to the question about claims to fame. You definitely know quite a few people right from your school age, of course.
Yeah. I mean, that's just one of those things that happens. I guess scientifically, you get to know famous people by being there a long time.
Yeah.
So, I mean, I know, name dropping too badly to say I know a whole group of people who won Nobel Prizes, but that's only because, you're long enough in a field
Yes.
that you do that. I mean, when I was an undergraduate, biochemistry in Bristol was one of the first places that actually accepted the chemiosmotic theory. It was thought to be the chemical theory that worked. You may not even have heard of it.
Mm-hmm.
And a guy called Peter Mitchell just lived in Cornwall, and he came up on a regular basis to the department and often taught us. So, to know people like that before they win the prize is something quite spectacular. And
yes.
we just thought it was normal. They decided we didn't have enough structural biology, so they stopped our lectures for 2 days, and they brought in Perutz, Kendrew, Perham, a whole series of these classical, famous, Fred Sanger, and gave us the money not only for the lectures, but actually to take them out for supper in the evening as well. And again, we just thought this was the way things happened in all departments.
Right.
And it's only relatively late on that you think back to that and you think, oh, wow, we were lucky. That was a really spectacular way to excite you about science and to introduce you to people who really did the seminal work in the field. And that was just wonderful.
Amazing.
Yeah, very cool opportunities.
Yeah.
I mean, the discussions you can have over a meal,
Sure.
relax, that would help as well.
Absolutely. Yeah, sure.
Yeah.
Sure.
Let's go. Last one. If not a scientist, what would you want to have?
I'd have given it all up to play cricket for England.
Yeah.
I was never good enough, of course,
Oh.
but it was always nice to dream.
Did you actually try out? Was there opportunities?
Well, there was opportunities when I was in my final 2 years at school to go and to be coached at Surrey at the Oval. That's what Bob Willis did. But I was concentrating then more on an academic career, and so I decided I wouldn't do that. I've never regretted that. I'm sure I wouldn't have been good enough. But, there was that pathway open to people who were good enough. Yeah. But I mean, if you're going to be a scientist, really, it has to be your life. You have to live it. I mean, even retiring now, I'm not going to be able to turn my mind off.
Yes.
I'm still going to be able to hopefully think about it and see things come on and take pleasure at other people solving the problems and producing nice new structures and things, but not doing it myself anymore.
I think that's very, very nice and selfless as well, because not only will you be wanting to come in and fill your own sort of void, but you're helping others with your...
Well, that's also fun.
Exactly, yeah. And people, I'm sure everybody would love to learn, if in research especially, to learn from people who have done it for so long, and from their mistakes or learn from their successes. So I think that's amazing.
Well, that was a lovely chat. Thank you for joining us. And we hope you enjoyed it as well.
Well, thank you for giving me the time to go on. Well, I hope you realise that I'm passionate about some of these things.
No, absolutely.
And that's really important. And I hope that you'll find your passions and that your careers will be as successful, and there's no reason why they shouldn't be.
Thanks.
Thank you.
Thank you very much.
Thank you very much. Thank you. Do join us for the next one. Bye-bye.
Bye for now. Thank you.
Bye-bye.